In this section, we're going to talk about something called the dot product and how we can use the dot product to help us solve some physics problems. So let's get started. Let's say we have two vectors and we're talking about things in two dimensions, so I and j, but we could branch this out to multiple dimensions. So we have vectors v written in terms of I and j, and we have vectors w written in terms of I and j. If we want to find something called the dot product, what we do is we take this number times this number plus this number times this number. So we multiply the numbers in front of I together plus multiply the numbers in front of j together. Let's look at an example. So suppose we have vector v as 2, 5, and we have vector w as -3, 7. And we want to find the dot product. So look at the notation here. It's just a simple dot in between v and w. It looks like a multiplication sign, but it is not a multiplication sign. To find that value, we're going to multiply the x components together. So 2 times -3, add, and multiply the y components together, 5 times 7. So we're going to get -6 plus 35, which is 29. Okay, now one thing I want you to notice with the dot product, we're not going to get a vector. A dot product is a scalar value. Okay, so all that means is we're just going to get a number, not a vector, but a number. Let's do another one. Let's say that v is equal to -1, 3, and w is equal to 2, -4. Then v dotted with w would be -1 times 2 plus 3 times -4. So -2 minus 12 would be -14. Okay, again, we get just a number. Okay, even if we were written in IJ notation, so let's say vector v was 4i plus 3j, and w, let's say, is I minus j. Then v dotted with w works the same way. It's going to be the x component, so 4 times 1, plus, and then the y component is multiplied. 3 times -1. So 4 minus 3 is going to give us a 1 for that value. Let's look at a couple of properties. So first thing I want you to notice is that this is going to be commutative, okay? Which means order doesn't matter. So if I take u dotted with v, I'm going to get the same thing as v dotted with u. So I'm going to show that in that last example. Let's say we have w dotted with v. W is going to come first. So the x component's 1. The x component of v is 4, plus y component of w times y component of v. So notice I've got the same numbers that I'm multiplying together. And remember, we can multiply in any order. So we're going to get that same value. So order doesn't matter. There's a distributive property that we can think about. If we have vectors u dotted with v plus w, I could think about u dotted with v plus u dotted with w. So they're kind of distributing that dot product to both of those pieces. And then we've got a dot product plus a dot product, which means I'm going to get just a number for that value. Next property, if I have something dotted with itself, it's going to be the same thing as the magnitude squared. So let's look at that. Let's say we have vector v, and I'm just going to be very generic and call it AB. If I take v and I dot it with itself, it's going to be a times a plus b times b, which is a squared plus b squared. Now, to show that it's equal to the magnitude, let's find the magnitude of v. So our magnitude formula says it would be the square root of a squared plus b squared. And if I were to square both sides, then we would have the magnitude of v squared is equal to a squared plus b squared. And we can see that that's the same as what v is dotted with itself. And then if I take any vector and dot it with the 0 vector, I'll always get just the number 0. Now we can use the dot product to find the angle between any two vectors on the Cartesian plane. So cosine of theta is going to be equal to u dot v over the magnitude of u times the magnitude of v. Let's look at an example. Let's say we have vector u as, let's do 2, 3, and vector v as negative 1, 4. So let's think about what these vectors look like. So just going to draw a rough sketch here. 2, 3 would be vector u. Negative 1, 4 would be vector v. And we're looking for the angle between them. So we're looking for this angle value. So I need to find u dotted with v. So it's going to be 2 times negative 1 plus 3 times 4. Negative 2 plus 12 is 10. I need to find the magnitude of u, which is going to be the square root of 2 squared plus 3 squared, or square root of 13. And I need to find the magnitude of v, which is the square root of negative 1 squared plus 4 squared, which is the square root of 17. So cosine of theta is going to be equal to 10 divided by square root of 13 times the square root of 17. And I'm going to simplify that. 13 times 17 is 221. And then now we're going to make sure we're in degree mode. Whether you're using Desmos or your calculator. To find theta, we're going to take the inverse cosine or the arc cosine of 10 over square root 221. And theta is about 47 degrees. So that angle between those two vectors would be about 47 degrees. Okay, let's try another one. This is where you may want to write down the example, pause the video, try it, and then come back and check your answer. So let's let u be 4, 1, and v be negative 5, 2. We're finding the angle between. Pause the video, try it, come back, check your answer. So we need to find u dotted with v. So we're going to have 4 times negative 5 plus 1 times 2. Negative 20 plus 2 is negative 18. We need to find the magnitude of u. So square root of the quantity 4 squared plus 1 squared, which is the square root of 17. And we need to find the magnitude of v. So the square root of negative 5 squared plus 2 squared. So 25 plus 4 is 29. Square root of 29 is the magnitude of v. Set it up. Cosine of theta is going to be equal to the dot product divided by the product of the magnitudes. I'm going to simplify that before I try typing it in my calculator. 17 times 29 is 493. So I want you to notice that at this point, we're taking the inverse cosine of a negative number. And since we're taking the inverse cosine of a negative, we know we're going to get something between pi over 2 and pi. Okay, just because of inverse properties of cosine, that's where the cosine would be negative. So we're going to get an obtuse angle here. So inverse cosine of negative 18 divided by the square root of 493. I got theta to be approximately 144.16 degrees. Okay, if you think about what the picture of this would look like, that makes a lot of sense. Because we've got vector u that has a terminal point of 4, 1, and a vector v that has a terminal point of negative 5, 2. So you can see from the drawing that there is a rather large angle between those two vectors, and that's the value that we just found. Okay. So we could analyze this guy a little bit further, right? Because we know that denominator is always going to be equal to 0 because magnitudes are always positive. So what happens to this angle really depends on the dot product. If u dot v is a positive number, then we know we're going to end up with an acute angle. Acute means that it's between 0 and 90 degrees. If u dot v is negative, then we're going to end up with an obtuse angle. So we're going to get something between 90 and 180. And if u dot v is 0, then we know the inverse cosine of 0 is 90 degrees. And what that means is that u and v are perpendicular. And another word for perpendicular is orthogonal. So we can start talking about orthogonal vectors or perpendicular vectors. And that's only going to happen when that dot product is equal to 0.